Hi, I'm Praveen. Today we're going to talk about discrete structures, teaching tutorial, chapter 4 relations. Sets. The objective of sets are students should be able to know how relation is being built. That is very important as we learn. And another objective of sets is students should be able to apply relation and combine the knowledge with other topics in these subjects. One of the subtopic of set is product set, where product set is an order of a pair AB in which A and B will appear in dedicated order. A appears first, whereas it's followed by B. This is very important because it will explain on how to solve set questions. Especially, there comes the next point. If two set A and B are non-empty set, its product set for A times B or named Cartesian product is a set of all AB pairs in which A set A and B set B. The next point is it returns as A times B equals in a subset A plus A comma B and A set A and B set B. The next part is relation. First point, a relation between two sets where its value was determined by a condition. All elements in their relation must fulfill the condition. In order to do this, you have to ensure all elements should be the right ones. Second point, let A and B are non-empty set, which is a relation from A to B is a subset for A times B. Third point, if R A times B and A comma B in a bracket, so R, we say that relates to B through R and we write as ARB.
Hi, my name is Guru Bhaskar and thanks to Praveen. For example of a relation is let A is 1, 2, 3, 4, 5. Define the following relation R less than on A. R is a relation less than on set A. More A, R, B if and only if A is less than B. R is 1, 2, 1, 3, 1, 4, 1, 5 or 2, 3, 2, 4, 2, 5 or 3, 4, 3, 5, 4, 5. Sets arise from relations. So, when there is a relation from A to B, we can find domain and range for the relation. Domain for R is elements in set A, that is, dom R is a subset for A is the set of all first elements in the pairs that make up R. Range for R is elements in set B, that is, ren R is a subset for B is the set of elements in B that are second elements of pairs in R. For an example, let's say A 1, 2, 3, 4, 5. Define the following relation R less than on A. R is 1, 2, 1, 3, 1, 4, 1, 5 or 2, 3, 2, 4, 2, 5 or 3, 4, 3, 5 or 4, 5. Dom R is 1, 2, 3, 4, whereas ren R is 2, 3, 4, 5. Relation representation. A relation can be represented in three ways, which is a set, in a matrix, or in a digraph, directed graph of R.
Hello, my name is Santosh. Today I'll be talking about degree. Degree is an important concept in relation. Example, if R is a relation on set A and A is equals to set A, then in degree for A is the number of B equals to A, where B, A and R are union. Out degree for A is the number of B, A, where AB equals to R. For the above, its degree are, in the as shown as the text above, vertex A, B, C, D, in degree is 3212 and out degree is 2411. The following table shows how degree is explained. Pi 1, 1, 2, 5, 4, 3 is a path length 4 from vertex 1 to 3, whereas pi 2, 1, 2, 5 and 1 is a path length 3 from vertex 1 to itself. Pi 3, 2, 2 is a path length 1 from vertex 2 to itself, whereas pi 4 is equals to 2, 5, 1, 2 is a path length 3 from vertex 2 to itself. A path that starts and ends at the same cycle is called a cycle. Pi 2, 3 and 4 are all cycles. Pi 3 and 4 are cycles that starts and ends at the same vertex but different lengths. In example as explained in the table above, pi 3 is cycle length 1 respectively. It is clear that paths of length 1 can be identified with the ordered pairs xy that belongs to R. Paths in relation of R can be used to define new relations that are quite useful. Next, if n is a fixed positive integer, we defined relation Rn on A as follows: x Rn y means that there is a path of length n from x to y in R. Last but not least, we may also define a relation R infinity on A by letting x R infinity y mean that there is some path in R from x to y. The length of the path is dependent on x and y. Thank you.
The relation R infinity is sometimes called the connectivity relation for R. Note that Rn to the power of n bracket x consists of all vertices that can be reached from x by means of a path in R of length n. The set of R infinity x consists of all vertices that can be reached by x by some path in R. Path length n can be found using set, matrix, or digraph representation. Next, we have the relations, the properties of relations. Relation has few properties that have to be identified clearly, such as reflexive and irreflexive. A relation R on set A is said to be reflexive if A bracket A R for all element A, that is A R A for all A R. A relation R on set A is said to be irreflexive if a R A for all A. Then we have symmetric. A relation on a set A is said to be symmetric if there is a R, B, then R. Relation is said not to be symmetric if there is A and B, A but A. It is relation sibling between A and B. Then we have a symmetric. Relation R on a set A is said to be symmetric if there is A, then B. Relation is said not to be symmetric if there are A and B. Both A and B are exist. It is a relation of mother of between A and B. Last but not least, we have antisymmetric. A relation R on a set A is said to be antisymmetric if there's ERAB and BRA and then A equals to B. That is, if A is not equivalent to B, then RB or BRA. Relation is not antisymmetric if A does not collide with B and there is both ARB and BRA.
Thank you, Rushil. Next, I'm going to talk about the example of reflexive question. What is reflexive? Reflexive is all elements that have relation to itself. For an example, the given set is 1, 1, 2, 2, and 3, 3. For matrix, the values on its diagonal are all 1. Basically, uh, everything at the side got to be 1. So that is what reflexive. And for digraph, they must have cycle length 1 on each vertex. Next, I'm going to give an example for irreflexive question. Irreflexive. Set U minus R matrix all value on its diagonal is 0. Before this, reflexive all diagonals are 1. and here everything must be 0. That is what irreflexive is. It's so similar to reflexive, but here everything have to be 0. It's not like reflexive. Next is digraph. The digraph. There is no cycle length 1 on each vertex. Next is symmetric. What is symmetric? Symmetric is basically a relation R on set A is said to be symmetric. If there is ARB, then BRA is the symmetric. You all understand? If BARB, that means you got to change it to the opposite. It will be BRA. That is what we call symmetric. Here are some example questions for you all to understand more about symmetric. Okay. Next is asymmetric. What is asymmetric? Asymmetric is a relation R set A is said to be asymmetric. If there is A or B, then B not equals R A. That is asymmetric. A relation is said not asymmetric if there are A and B element A. Both A and B and B are A are exist. It is like a relation, mother of between A and B. That is asymmetric. Here are some examples of asymmetric questions for you all to try and see. Let me explain briefly about the questions. Given set 1, 2, and 1, 3, and 2, 3. Metric values not symmetrically on the diagonal. Diagonal entries must be all 0. What does that mean? At the side and bottom, everything got to be 0 and the diagonal have to be all 0. If everything is all 0, it is known as asymmetric. And for the digraph, there must be no two-way and no cycle length 1 for all vertex. This hope you all understand, and thank you everyone. Thank you everyone for listening to our tutorial video. Hope you all liked it. And this is our group members. First we have me, Vinod, Praveen, Rochelle, Guru Bhaskar and Santosh. Thank you everyone.